right. Good morning, everyone. Very glad to be here at the Data Integration Summit. So before I start, let me quickly introduce myself. My name is Sanjay Reddy. I'm one of the chief architects at Vanguard Data and AI. For people who don't know what Vanguard is a asset management company. We are almost around $8 trillion AUM. I think fluctuating based on the stock market. Yeah, and I've been in this role for almost 3 years now. So today, actually, I'll be talking more about some of the challenges on data integration and challenges what a data analyst, data scientist, engineer also faces, and how you can resolve this. At least some patterns. What are some best patterns we could use to overcome these integration challenges? Before I start, I thought it's always good to start with some did you know or facts. And the funny fact is, the other day I was talking to my daughter, and she said, "Do you know how much data a human being generates?" And she did ask me, like, how much data does a human brain capture? I didn't know that, but then I was googling, of course, asked ChatGPT, and it said we generate almost 1.7 MB of data per second. And that got me curious, and I said I need to find out, like, hey, how much data are we storing worldwide? And that, according to Data Universe, we estimate almost like 180 zettabytes of data by 2025. And that's like 180 billion 1 terabyte disks of data. Man, that is something, right? So, and that's going, it's growing. It's not stopping. So we are capturing more and more in data. Uh, and according to U.S. Bureau of Labor, now get all the data. What do we do with the data, right? That's where the data analysts, data scientists come in, and they give us they find insights of this data, right? And according to U.S. Bureau of Labor, they say, like, there are estimated growth of 35% of data analysts and scientists between 2022 to 2032. And the market size for data analytics as of 2023 was 308 billion, 307 billion, and it's projected to grow almost to a trillion by 2032, according to Fortune Business Insights. And you see the graph, right? So data is growing. There's a lot of challenges as data grows, especially for data analysts, data scientists. And to keep up, you need data engineers too, right? But there are some aspects where a data analyst or data scientist should be able to go integrate the data and find insights, right? And that's what we're going to talk about in the next slide. I'm going to talk quickly on a common architecture and challenges. As you see this, right? And this challenge is not just for data analysts or data scientists. I say this is for even data engineers or anyone, right? We, as a community, we grew from a more deductive, right, based architecture, that is data warehouses, to, like, hey, what happened? Why did it happen? To more inductive, right? What will happen? How can we make it happen? And now, in some cases, actually, we've gone into an objective mode with Gen AI making decisions for us, right? It's actually making a best decision with the information in hand. And the best example is your cars, home automation, right? It's able to predict a lot of things and make a decision for you, applying brakes when there is a hazard or something like that. It's decision making, right? So the growth of data analysts and the scientists is increasing by day, and the need for the data access is important. Now, when we talk about this common architecture, right? One of the things which I want to mention here is, if you look at this data architecture, this is fine. This is not a bad architecture, but some of the challenges I want to emphasize here is, and again, I want to emphasize one more thing is, this is in no way promoting or bringing down a technology. Every technology here is good. Use a technology which fits your purpose and use case, right? This is just an example. Say, for example, we have data, and there are a lot of organizations keep data in, like Redshift, Snowflake, Databricks, um, vendor tying technology, right? The challenge we face in day to day is, a data analyst or data scientist, or even a data engineer from another division wants to access the data, and you go to a marketplace and I say I need access to this data sitting in this particular cloud data warehouse, the consumer, right, may not have the same technology as a producer. That means, like, if the data is produced in Amazon Redshift or in Snowflake or in Databricks, for that matter, right? The consumer should have the same technology. For example, if I need to access data in Amazon Redshift, I need to have access to that Amazon Redshift box, or I need to spin up my own compute Amazon Redshift box and do a data share. Now, from another division, from a consumer's point of view, all I say is like, hey, all I need is just access to your data. I want to build a vector DB to build my RAG. I just want to build some transformation to build some other data product. All I need is access to your data. Now, if the producer says, hey, the only way you're going to access this data is coming through one door, and that one door is through my vendor technology, that could be a Redshift or a Snowflake or Databricks or anything, right? That's a challenge here, right? That's a big challenge here. Now, who's going to pay for the compute? Is it the producer or the consumer, right? Say if you go as a consumer, say you spin up a data, right? You as a consumer, you spin up the same technology. In my opinion, it's a wastage of compute here. You're spinning up a compute for just consumption, or there's already a compute running elsewhere. In most cases, what happens is I want to copy the data into my environment because I don't want to keep going to the producer's environment because I need to spin up a compute just to access it. It results into data copies, right? Wastage of compute. Or if the producer says, "Hey, just access my data in the warehouse what I have," then you need to have some kind of a read logs because you are updating something on the table. You want to avoid non-asset compliance, so you put some kind of a read log. There's so many cons here, right? And lastly, I want to say is vendor tying technology, right? So you're tied yourself to this particular vendor, and especially in this day and age when data is so important to generate any kind of insights, you need that open door, multi-door policy, not just one door. And these are some challenges we face in our current needs, right? Those are some patterns I'm at. What is that we would suggest, right? Moving forward, what is that we want to see is a modular based architecture, right? What that means is a a architecture which is scalable and more modular, right? And this architecture, I'm sure you have seen it. You have the cloud storage, and people, there is some kind of a movement going on to move towards open table format. And that likely so, that's because they don't want to tie into a vendor technology, and they want to keep it more open so that you can bring any compute what you need to access the data as long as it can read as long as it can read that open APIs or libraries. So there's cloud storage, open table formats, bring your own compute, be able to generate analytics and insights, uh, bring your own tool, right? That's the architecture pattern we are kind of moving towards. Now, going to the next slide, and as I said initially, not promoting any technology or not putting any technology down, right? If you look at the slide, this is a open architecture, right? Um, when I say open architecture, here moving forward, the community is moving towards open architecture framework, where, as an example here, is Iceberg, right? There's Delta Lakes, there's Hoodie. A lot of people, and as I said, like, go with the use case which fits your purpose, right? Use case purpose. This is just an example. I put Iceberg in there. Hoodie is there. So is Delta Lake. There's many technologies you can, three formats. Feel free to use anything. You put Iceberg in here, and you could technically bring any technology in here. So the producer can say, you know what, the data is sitting in Iceberg in S3 bucket or in Google Cloud Storage, and the consumer can just use the compute whatever they already have or they want to use to access the data. There is no any kind of contentions here of who's going to pay for this compute, who shouldn't, right? We are, and with this, what we are designing is a more modular architecture that can evolve to the future, like to the as AI models are built, use cases are getting are coming in. You can just scale based on your use case and accessibility patterns, right? That's a beauty of this open architecture. It's good, right? So this is great when we are moving forward from moving to the future state architecture. Now, starting now, I'm this is what I'm going to do. This is great. Now the challenge is what happens to uh, the organizations who already invested into many cloud data warehouses, right? What happens to them? Are we saying that migrate, do another migration? There's many ways we can solve this, right? This is great if you're starting off, but then if you move towards the next slide, right? If you look at this, whatever was there in the previous slide, right? The iceberg, uh, bring your own compute, be able to detect your or get to the insight. Leave it as is. Start building your uh, data products in this architecture, but at the same time, you need to get access to the other data sources, such as your open cloud data warehouses, which are sitting in Amazon Redshift or Snowflake, or even for that matter, on-prem, right? This is where the integration layer comes in, right? You also have compute to access your open formats, but you need an integration layer. There are many tools out there which is going to resolve this, right? By bringing an integration layer, you are, or the main goal of this integration layer is to provide that unified, accurate, real-time view of data across your organization, right? This should even enable a seamless information flow um, for better decision making and improved operational efficiencies, right? End of the day, you're enhancing your business operations by bringing this integration layer. With this pattern, you're also you can scale as you need. What that means is if you want to scale any of these components, like say, I want to get a different technology, you should be able to replace it, right? Whether it's in the compute environment or in your BI tool, you're not closely tied. Although you're closely linked, you're not dependent on that, right? So that's this is the pattern we are kind of promoting as we move forward. Not everything needs to be in this architecture, right? If your organization already has small amount of data and it's not in terabytes and petabytes of data, it's in a few gigabytes, a few billions of data, go with the cloud architecture. It's going to solve your use cases. You don't have to worry about, hey, I'm trying myself to a vendor technology, or moving into this architecture, you're going to lose something. Now, you're not going to lose anything. There's nothing wrong in moving to this architecture. You probably might attain a parity, but nothing wrong if you want to stay with your cloud warehouse. But if you are an organization which is more having more petabytes of data, terabytes of data, you're processing, their cross-divisional access, there's contentions, then I say this architecture really flows well, especially when you go into the open architecture and putting an integration layer on top. It's going to be able to find insights, quick insight to your data as soon as quickly as possible. Scalable, it can handle large data sets, high-speed data processing, and it can even handle increased workloads because it's modular in place. And this also, and this pattern also works for real-time data processing, right? It can support real-time data. You can stream data right into Iceberg, or there's zero ETL going into Redshift or any other technologies, and the integration layer can just real-time be able to find insights on the fly, right? I would end this by saying, let's build a data architecture that drives the future. So, thank you everyone for attending this session, and I'll be happy to answer any questions. Feel free to post them.